Today, we're going to take a look at our last set of notes for our exponentials and logs unit. We're on page 60 to start for today, and we're going to talk about solving logarithms. So the last topic that we covered was how to solve exponential functions. Now we're going to talk about how to solve logs. Remember when we looked at how to solve exponential functions, one option was to equate the exponents. So if we had the same base, we could set the exponents equal. We could also rewrite our exponential function as a log. Or we could take a log of both sides, and we looked at taking a common log and a natural log. Today, for solving logarithmic functions, we're going to use some similar strategies. So one option we have is to take our log and rewrite it as an exponential function. So this would be 4 to the second power equals x. So if I simplify over here on the left, 4 squared is 16, so that means 16 is x. We could also, instead of equating exponents, equate the argument. So if I have a log on both sides of the same base, so since I don't see a base here, that means that it's base 10. If I have a log on both sides with the same base, that means that the arguments have to be equal, so we can set them equal. So x plus 3 equals x minus 4. I'm going to move the x's to the same side. And here, our x's would be gone, and we get 3 equals negative 4. We've seen things like this in other functions that we've solved where our variable is gone and we get something that's not true. So when that happens, that means that we have no solutions. We can, if we need to, combine logs before we rewrite. So if I've got multiple logs on the same side, we can use our properties of logs to be able to condense this. So this would be log base 2 of, since I'm adding, I would multiply these arguments. So 5x equals 3. And now I can rewrite this as an exponential function. So this would be 2 to the third power equals 5x. So 8 equals 5x, which means that x would be 8 over 5. And we can also, if I've got logs on both sides, condense wherever I've got multiple logs and then equate arguments. So here, again, since I'm adding logs over on the left, I can rewrite this as a single log base 2 of 5 times x equals log base 2 of 15. And now that I have logs with the same base on both sides, I can set the arguments equal. And so here I would get x to be 3. And then just like with our exponential functions and every other function that we've talked about this year, we can also find our solutions by graphing. You can also check your work by graphing. So let's look at a few more examples. On page 61, since I only have a single log here, I'm going to solve this by rewriting it in exponential form. Now, before I rewrite it, I want to get the log by itself. So I'm going to go ahead and divide this 2 to the other side. So I have log base 7 of negative 2r equals 0 divided by 2 is 0. So this would be 7 to the 0 power equals negative 2r. Anything to the 0 power, including 7 to the 0 power, is just 1. So I get 1 equals negative 2r. Now divide both sides by negative 2 to get r by itself. And we get r to be negative 1/2. If I have a log on each side, then we want to think about equating the arguments. So since I've got log on the left and a log on the right, they have the same base. So I'm going to equate their arguments. So negative 2a plus 9 equals 7 minus 4a. I'm going to move my variables to the same side. So I'm going to move this 4a over. So that would be 2a plus 9 equals 7. Now we're going to move the 9 to get the a's by themselves. So 2a equals negative 2. And divide both sides by 2 to get negative 1 for a. The other examples we're going to look at are just variations on this. So if I've got multiple logs on the same side, I probably want to combine them. So since we're adding here, that means we're going to multiply our arguments. So log of 2 times x equals 1. And now, since I have a single log equals a number, I'm going to rewrite this in exponential form. Remember, when I don't see the base for my log, that means that it's 10. So this would be 10 to the first equals 2x. 10 to the first is just 10. And here I would get x equals 5. For example 4, on the left, I've got multiple logs, so I'm going to combine them into one log. So this would be log base 9. Since we're subtracting, this will be written as division. So the first thing, the first argument, divided by the second argument. And the right has stayed exactly the same. Now that I have one log on each side and the bases are the same, we can equate the arguments. So this would be x plus 6 over x equals 2. So I have a little rational function here. So I'm going to write this 2 as over 1, and then we'll solve by cross multiplying. So this would be 2x equals 1 times x plus 6, which would just be x plus 6. Move our x's to the same side, and we get x equals 6. I would like you to try the U-try problems now. Take just a minute on those. Go ahead and pause the video if you need to. And now let's take a look at these together. So I've got one log on each side. That means I can equate the arguments. So negative 11x plus 2 equals x squared plus 30. Since I have an x squared term, that means I'm going to need to use a quadratic method to solve this. Since I have x squared and x, that means I'm going to want a factor. So I'm going to move everything to the same side. And I get 0 equals x squared plus 11x plus 28. So factored form for this would be x plus 7 times x plus 4. And my solutions would be x equals negative 7 and x equals negative 4. For example 6, I've got multiple logs on the same side, so I'm going to combine them by rewriting using those log properties. Since I have subtraction, I'll rewrite this as division. So x minus 3 over x minus 5. And we see the natural log here. This is the first example that we've seen natural log, but remember it's just a log, so I treat it the same as I've treated all of my other problems. And now that I have log equals log, I can set the arguments equal. So x minus 3 over x minus 5 equals 5. And again, I have a little rational function here. So I'm going to write the 5 is over 1 and cross multiply. So this would be 5 times x minus 5 equals x minus 3. You need to distribute here. So that would be 5x minus 25 equals x minus 3. I'm going to move the x's to the same side. So we have 4x minus 25 equals negative 3. And then I'm going to move that 25 over. So I have 4x equals 22. Divide both sides by 4 to get x by itself. And if I would reduce this, I would get x equals 11 over 2, or 5.5 if you'd rather. So that's solving logs. Similar strategies to what we looked at with solving exponential functions. I can rewrite them as exponential functions. If I've got a log equals a number, rewriting is a good option, or we can equate their arguments. And again, we may need to, if I've got multiple logs on the same side, use those log properties to combine before I use either of those strategies.